we're going to review this application. I downloaded it. It's available on Canvas. The display's not on, so you can't see it anyhow. If you go under modules, under week 8, actually under week 8, 9, you'll see example from tutorial lecture, Contoso University. There's also a link to information about this tutorial and this application. The big topic today is about relationship between entities in a database. And those of you who had CISS243, you're probably familiar with the different sorts of relationships. We're going to revisit those and review those, but then we're going to look at how they get implemented in our ASP.NET Core. So what I want to do is I want to start with this application and show you some of the functionality in this application, and then we'll talk about the entities in the application and the relationships between them. So if you download this application, the one thing you have to do is you have to update the database. So I've already done that just to make sure there weren't any errors or whatever, but when you download it, you have to run update database. After you've done that, you should be okay because this database structure is not going to be changing at all. I have to do it every time because every time this computer gets wiped. So the database that I had before is gone, like if I talk about this again next week. All right. So let's run it and see what we get. This is meant to be an application for a college, very small college, as you can see, because it doesn't have too many students. I have too many courses either, or instructors. I'm going to point out the important stuff in this. First of all, we have a student entity, and that contains information about the student and course. Now, the student entity, if we look here, has a relationship with courses. So two of the entities we have is that we have, and let's write these down so we don't forget. We have students and we have courses. Right? That's two of the entities that we have so far. We have a course entity. And a course is associated with a department. So two more entities that we have are course and department. I'm just listing them here, not saying anything about the relationship between them here. Although we can kind of determine that from this, how it's used. So the other things that we have besides courses and instructors and departments we're going to see if this has a list of students. It doesn't seem to, but it does have the department that it's associated with. Department also has an association with instructors because there is an administrator who belongs in the instructor table. So each department has an administrator. And I think that those are the entities, unless I'm missing some. Student, course, instructor, departments. Yep, that's the individual entities. Now, how they're connected, we're going to see, we're going to talk about now. And again, this is where you got to put your real world hat on and come to some decisions. Now, as far as database relationships go, there's three kinds of relationships in a database. And we have to know how to implement at least two of them. The third one, we're not going to worry about. First kind of relationship is a one-to-many relationship. So it will be indicated on a entity relationship diagram, something like this. One to many. And what that means is this entity here, entity A, has many B's associated with it. But each B has only one A associated with it. So where we see this an example of, where we see an example of this is between departments and courses. All right. One department can have many courses, right? Here we have the CISS department. There's many courses in it. There's CISS 216, CISS 232, CISS 243, and so on down the list. So one department can have many courses. Each course, though, only belongs to one department. So, for example, CISS 216 is a CISS course. It belongs to the CISS department. It doesn't belong to CISS and accounting. All right. At least not in this particular example. There could be a college where there are courses that are cross-listed between a couple different departments. But in this example that we're going over, that isn't the case. The course belongs to one department. So a department has multiple courses. So CISS department has CISS 216, CISS 232, CISS 243. But each individual course, CISS 243, for example, belongs to only one department. That is the CISS department. And that's what this means, one to many, and sometimes it's designated with those crow's feet. Now, to correctly identify a relationship, you have to look in both directions. So you have to say one of these can have how many of these? One of these can have how many of these? So one department can have many courses. A given course is only for one department. So that's an example of a one-to-many relationship. That is probably the most common form of relationship. The other two types of relationships one of them is a one-to-one relationship. And those you have to be careful about because not a lot of those exist in the real world. I guess some of them might exist. I'm trying to think of a good example. Let's ask ChatGPT. Is an example of a one-to-one relationship in a database. They show this example, but this is kind of a goofy example. The relationship between users and profiles. One user has one profile associated with it. If I were doing this, I'd ask why those aren't all in one table, because I would just make a users table that had phone number and address to it. An example of an optional one-to-one relationship might be the relationship between student and visa information. So for example, students that come and go to college from other countries have a student visa. And there's some information about that, the student in that visa. There's the country that issued it, there's the date it expired, I'm sure, there's the type of visa it is, and there might be some other information. Well, one of those visas only applies to one student. And one student is only going to have one of those visas. So that would be maybe a better example of a one-to-one relationship. But we're not going to really consider those because none of our relationships in this case are one-to-one. And really, a lot of times when you look closely, you'll find that what you might think is a one-to-one relationship might prove to be a one-to-many relationship. So we're going to not really worry about one-to-one relationships. The third kind of relationship that we will worry about is a many-to-many relationship. One of A has many B's associated with it, and one B has many A's associated with it. Think for a second to yourself, if you can think of, in this scenario that we've painted here, of this college problem that we're trying to solve, this college application, where we might have a many-to-many relationship. You don't have to raise your hand if you don't want to, just think to see if you can come up with a many-to-many relationship. Probably the most obvious one is a relationship between courses and students. One course can have multiple students, right? In this course, I don't know how many students there are, but I can look in the classroom and on WebEx, I can see there's more than one student, all right? Remember, in database, we're less concerned about the specific number than we're concerned if there's more than one. So really, the numbers in database design are 0, 1, and many, all right? That's all we're concerned about. Is there many or is there only one? But a course could have many students, all right? That makes sense. Each one of your courses probably has multiple students in it. Now, the flip side is also true. A student can have many courses. Now, you might say, well, I'm a student and I'm only taking one course, let's say. Well, yeah, but you could take more than one. So a given student can have associated with them more than one course. So in database terms, this is a many-to-many relationship, and it will actually get stored in the database as a series of 2 one-to-many relationships. So courses to students, we would put in an intermediary entity called enrollments, where each enrollment has one student and each enrollment has one course. So this matches up. So if we had course 1, course ID 1 and student ID 1 in this table, that would indicate that course ID 1 has student 1. Course ID 1 may also have student ID 3, and so on down the line. So between department and course, it's a one-to-many. Between course and student is a many-to-many. Now, some of these we have to look at because it could depend on how the particular institution does things. For example, who teaches a particular course? All right. Let's look if we can get any knowledge about that from here. Actually, we can associate one instructor can have many courses, and a given course can have multiple instructors. We have 2 instructors teaching chemistry. So we're going to draw this between course and instructor. Would also have a many-to-many relationship. How does department fit in? A department has a one-to-many relationship with courses, and the department also has a one-to-many relationship with administrators. So a given professor can be an administrator of a certain department. And one administrator can cover 2 departments. So it would be one department has many instructors. A given instructor can be administrator for one department, for more than one department, rather. Okay, let's make a new document here. So we have student, course. It's a many-to-many relationship. Instructor to department is a one-to-many. A course to department, or department to course the one-to-many, and an instructor to course is a many-to-many. So we could draw this. Course, student, instructor, department, and department to course. That. I think that's what we got in this. Anyhow, so let's look at the application, and we'll start with one simple one. Relationship between department and course. Okay, let's look. Let's look at how that works behavior-wise. We have a department. And we have a course that has a department associated with it. So you notice that each of these courses can have one department, but a given department can have multiple courses. So that's a one-to-many relationship. So let's look to see how that's implemented. To look to see how that's implemented, we have to look at the models. So let's first look at the model for course. All right, notice what this has as properties. It has an attribute for a department ID. That means we're going to store with the course the department ID to which it belongs. All right. We also have associated with the course, we have a department object that, depending on the query we perform, we may or may not fill that in. In some cases, we might not be interested in the department. In other cases, we are interested in the department. So we could get just a plain old list of courses, or if we wanted courses sorted by department, for example, we could link up between course and department and get the department information associated with each course. So this is the many side of the one-to-many, all right? Because one department could have many courses. So each of those courses has these two things in it. The first thing, the public int of department ID, is what's called the primary key of that entity or that table. The primary key is something that uniquely identifies a member of that table. So each department has an ID associated with it. Now, we may not see that ID on the screen, but it's there behind the scenes. And it gets generated in the database as an auto number column, an auto increment column. That if we look at the database, we can actually see it. So if we look, for example, at the course table, we see that this course for calculus belongs to department number 1. That's what we get in the database. And if you're familiar with databases, keep this in mind. But remember, we're not dealing with databases on the model side. We're dealing with models of entities and the objects that are associated with those entities. So this belongs to department 3. And if we were to look at department 3, we would see department 3 is mathematics. Now these fields we look at that, we can see the department ID is an integer, and it is what they call an identity. An identity means it identifies uniquely a row in the table, which means, first of all, it's going to be unique. So there's no two departments that have a department ID of 3. It also gets created automatically. But we don't have to put in a department ID. We store a new department, that gets generated for us by the database. Now, we're looking at the database just in case you've seen databases before and tables and keys and all that. But really, we're not interested in the database. We're interested in this. And what this says is essentially the same thing, just put in a different way. This says every course has a department ID associated with it. Well, the department ID that it belongs to. And it also has a department object. Now, what's a department object? Well, it's an object that contains all the fields for that course's department. So if we want to get the department name, we can get that. All right. And we'll see how they do that in a minute here. So this is a one-to-many. When you have a one-to-many, the many side has a pointer to the one. So that will include the primary key of the one side and a single object of the department. Now, if we look at the department table, we'll notice what the department table has. It has a list of courses, a collection. A collection is basically a list. So associated with each department is a list of courses, right? Because one course can have, associated with each department is a list of courses because one department can have a list of courses, can have many courses. Whereas one department or one course only has a single department. So all we get is the primary key to that and a single department object. Now, this is going to be a recurring theme. We're going to see this a lot whenever we have one-to-many relationships. And in fact, if there was a many-to-many relationship, then course wouldn't have a single one of these. It would have also a list of departments, but that's getting a little ahead of ourselves. Now let's see how this is used. So let's look at the list of courses. Let's go under pages. Let's look under courses, index. And we're going to look both at the CISS HTML and also the .cs file. Okay. When we run it, what do we get? Let's look at the output that this produces. When we look at the course list, we get a list of courses and we get the name of the department. Now, if you remember, the name of the department is not stored in the course entity. All we have is the primary key. So we have the ID of the course. The ID of the department in the database for each course. We have to look at the appropriate department object to pull the name or to pull other information out. So let's look at this. First of all, in our CS file, we have a list of courses created here. All right, list of courses, because this program is a listing of courses. All right, so we're going to have our model fill up a list of courses. So how are we going to do that? We may have seen this in previous examples. When this page is first loaded, we pull from the context courses table and we include departments. That's critical. This, and then we take all that and make a list. This statement here gives us a list of course objects that we store in this variable called courses. But we're including the department information. What that means is this information is going to get filled in. Now, if we weren't interested in the department name, we wouldn't need that. But we need some information from the department entity. So the course has a connection to the department entity, right? One course has one department. So we need to fill in the department info for that course. And that's exactly what this tells us to do. When we pull a list of courses, give me that list with the department object. This object right here. with it populated with the information from the proper department entity. So you may have looked, if you looked at this before in any of the examples, it looked like this probably, but it didn't include line 22. We include line 22 because we have related data. All right, related data to it. And what data are related? It's the department data. So now let's look at the index CSS_HTML, which should look about the same as we've seen before. We get the headers for those fields. We're looping through each course, and we're displaying the course ID, title, the credits, and, drum roll please, for that item, we're displaying its department's name. When we look back at the model for department, we notice one of the attributes in the department is the department name. Here we're saying we want for this item, and what's that item? It's a course, it's an item in the variable model course. What model course is? What does model courses consist of? It consists of a list of courses. So we're simply asking here at this point, give me for each course, give me its course ID, its title, and we want the name of the department. And the name of the department comes from the department object associated with that course and is the name attribute. That's why when we run this, these three things come from the course. This thing comes from the department associated with that course. And we can tell that from the code because we say item, or item is each item in our model course list, which is a list of courses. We want for that course, we want the department's name. So we use this dot notation, zero in on the particular field that we want. For these are associated with the course. So we just say item dot course ID, item dot title, item dot credits. Here, it's not associated with the item, it's associated with the item's department. So we say item department dot name. So we get this. Now, the next thing that we have that we'll start to look at, I don't know if we'll finish it today or not, is when we go to edit this or add a new course. Let's go to add a new course. We can pick the department that it belongs to. And there it puts it in. So let's look at the create. The create we have it does that this way. Let's worry about this next time. Come back to this next time to go over that. Let's look at some other models though, to look at how a many-to-many is implemented. So the relationship between course and student is a many-to-many relationship. And that's implemented through this enrollment entity. An enrollment entity contains the employee ID, or the enrollment ID, course ID, and the student ID, along with the grade that they've gotten. So if we look at the course has a list of these enrollment records, and the student has a list of those enrollment records. For the student, the enrollment records contain all the courses that that student is taking. For the course, that includes all the students that this course contains. So we don't have the case of like we had in the course where we have an individual department. In this case, because it's a many-to-many, we have lists on both sides of the many-to-many, and that implements that. Okay, this has been a rough semester for me health-wise, as you probably have figured out by now. I will in 2 weeks, so October 28th and 29th, yeah, October 28th and 29th, yeah. I'll be missing again because I'm having cataract surgery. So I should be back the following, I expect to be back the following week. I'll let you know if that changes. So I will probably post a little bit in advance for you to take a look at stuff. Next week, we're going to go over this some more because I don't expect you to get it after just one example going through it. But this gives you a chance to look through it. Do pay attention to the things I have posted in Canvas. So in this case, for week 8 and 9, I have how to do one-to-many relationships in ASP.NET Core. There's a video that explains essentially what I explained. And here is a document contains that. Hope you don't have to be logged on. You don't. Good. And this shows you just another example of a relationship between order and order item. You see, each order has one of these because each order item is associated with one order, but on the order side, there's a list of order items. So that's the key thing in doing these one-to-many relationships. We'll cover the many-to-many more next time. Are there any questions? All right. We'll either see you next week or up in lab. I will be, near as I know, I will be here next week.